My name is Juan Perez Bermejo, and I am a third year PhD student here at Gladstone Institute. And my program is bioinformatics, but actually my area of research combines both bioinformatics and wet lab biology in the field of stem cells. You know, when I was a kid, I was not really interested in science at all. I never thought I would become a scientist, and I never thought I wanted to be a crazy scientist or anything like that. I just became interested in biology just when I was about to graduate from high school. I got really distressed by the idea of having a job for the rest of my life that would be all the time the same and really like boring and monotonous. So I decided to do this new degree in biotechnology because I had been told that it was the most like dynamic and fun thing you could do where you would never be doing the same. So I jumped into it. And after I graduated from my master's, my boss put me in contact with a company, and I worked for a pharma company for some time. And when I was there, what I found is that in biology you need to use a lot of math and a lot of computer science skills to analyze the data, but then the biologists had no idea about that. And we had a team of computer scientists, but they didn't know anything about biology. So they really didn't know where the data came from or how did it look like or what. So I became very interested in this field where you combine both, and they call bioinformatics. So I applied for a PhD here at UCSF, and I got accepted, and here I am. So we know that some people have heart disease younger than many other people do. Some people develop heart disease when they are 30 or 40, and that is even when they have a very healthy lifestyle, but we don't really understand what's happening with them. So what I do in lab is I compare the cells from those people with the cells from people that are healthy, and I try to find what's different between them.
Two cells?
Yeah, these are nuclei, right?
Yeah.
But they are still very close together.
You're saying for DNA?
Yeah.
Yeah.
So usually what I tell the people is just imagine you're a clock worker, but you don't know exactly how the clock works, right? But you compare a clock that works and a watch that doesn't work, and you see which piece is missing or which piece is like messed up and it's completely different, and try to identify why that piece is causing the watch to not work. We discovered how some of these pieces work and why some of these pieces are not working properly in the people with heart disease. So I think in a future where I have discovered and my co-workers have discovered can be used to improve the treatment and the prevention of heart disease, which is something that I think I'm very lucky about. You know, many other people can spend years thinking about a specific problem and never find something specific, but I think we did already. I would say there are two main people or factors that encouraged me to become a scientist. In addition to doing science, one thing I enjoy a lot is teaching in general. Not only teaching science, but also even teaching like literature and language. So anytime I come, I volunteer to be mentor, or even here at the university or outside to teach other people, because I really love the way people show when they are learning something and how they interiorize everything. The other one is when I worked at the company, I got in touch with some patients. I thought that was very inspirational for me, mostly because sometimes you keep complaining about how hard doing science is and how it's not really that rewarding many times, but then you find out that all these people are actually living with their diseases and fighting with them, and the least that we could do for them is actually to try to help them through research, which is what we do. And at the same time, I feel like there's a gap between what we do here and the application. It's what they call the bench to bedside. And I think that gap needs to be closed, needs to be, got together. So hopefully in the future, and I hopefully will be able to see that, the discoveries that we do here will be translated into treatments. The community needs to understand that biology can not be as it's been traditional. It needs to focus even more on the patient and on the proper treatment to make sure everything gets translated into treatments. The way I could help to do that, for example, is to convince more people and to make some other people realize that that's the way science should go. Well, since I was a kid, I've always been creating my own problems and then struggling a lot to solve them, but I never gave up, and I always kept working ways to solve those problems. So to me, I like to focus science in very small problems, very small experiments, and come here every morning and say, today I'm gonna get this to work, I'm gonna get the results I'm looking for, I'm gonna do this thing. That is probably more than thinking about the big picture, it's also the small problems of every day that encourage me to keep coming here.